Welcome to G Fun Facts Online, your go-to source for the most amazing insights from the world of science and technology. Today, we're diving deep into a topic that's quietly revolutionizing our planet, the incredible advancements in materials science that are paving the way for a sustainable energy future. It might sound complex, but trust me, the tiny materials we're about to explore are making a giant impact on how we power our world. Think super solar panels, tougher wind turbines, and batteries that could change everything. So why are materials so important? Well, the pursuit of clean, renewable energy is inextricably linked to what these systems are made of. Innovations in materials science are absolutely crucial for making next-generation renewable energy more efficient, last longer, and, importantly, cost less. We're talking about breakthroughs in solar power, wind energy, how we store that energy, and even how we produce green hydrogen. Let's get into it. First up, let's talk about solar energy. The sun is beaming down an incredible amount of power, and scientists are getting smarter than ever at capturing it. One of the biggest buzzwords right now is Perovskite solar cells, or PSCs. These aren't your grandma's solar panels. PSCs use materials with a special crystal structure and have shown efficiencies surpassing 25%. That's potentially better than traditional silicon cells, which typically hover around 20 to 22%. Plus, perovskites are lighter, more flexible, and could be cheaper to make. Researchers are working hard on making them super stable and ready for mass production, with some experts predicting commercial-grade PSCs could hit the market by 2025. How exciting is that? But wait, there's more. Multi-junction solar cells are like a layer cake of semiconductors, each layer designed to capture different wavelengths of light. This approach has led to lab efficiencies soaring above 40%. And then there's quantum dot technology, tiny, nano-sized crystals that could theoretically convert up to 40% of sunlight into energy. Real-world results are already hitting around 18.1%. And scientists are rapidly improving them. Imagine pairing perovskites with silicon. That's what tandem cells do, and some are already achieving over 31.6% efficiency. We're also seeing Kesterite solar cells, made from common elements like copper, tin, zinc, and selenium, offering an eco-friendlier alternative. Recent studies in 2024 reported efficiencies over 14% for these thin film cells. Speaking of thin film, organic photovoltaics and technologies using materials like SiGs and cadmium telluride are leading to flexible, lightweight solar panels. MIT researchers even unveiled ultralight fabric solar cells. Imagine your jacket powering your phone. And don't forget bifacial solar panels that capture sunlight from both sides, boosting energy generation by up to 30%. The future of solar also includes transparent solar panels that could turn windows into power generators, solar skins for beautiful building integration, solar fabrics woven into everyday objects, and agrivoltaics, where crops and solar panels share the same land. The possibilities are truly dazzling. Now, let's shift gears and talk about wind energy. Material science is playing a huge role in making wind turbines more efficient, last longer, and more sustainable. Manufacturers are developing larger and more efficient turbines, and a lot of that comes down to the materials used in those massive blades. Lightweight, super durable materials like carbon fiber are being used to create longer blades that can capture more energy, even at lower wind speeds. And it's not just blades. Technical ceramics are being employed for components like bearings and gearbox housings. These ceramics can withstand harsh weather, resist corrosion, and allow turbines to operate at higher capacities with less maintenance. And how about this? For sustainable, wooden turbine towers using laminated veneer lumber are being explored as an alternative to steel. But what happens when a wind turbine reaches the end of its life? A major focus is now on recycling wind turbine materials, especially those tricky fiber-reinforced composites like fiberglass and carbon fiber, and the rare earth elements in generators. The U.S. Department of Energy even has a wind turbine materials recycling prize to fund research into cost-effective recycling. We're seeing cool new methods like pyrolysis to reclaim fiberglass, and even developing resin-bonded coatings for concrete made from shredded blade waste. Some companies are even designing blades with resins that dissolve more easily, making it simpler to separate and recycle the components. And for a bit of creative reuse, imagine an old turbine nacelle being transformed into a tiny house. Okay, so we're generating all this clean energy from the sun and wind, but what happens when the sun isn't shining or the wind isn't blowing? That's where energy storage systems come in, and advancements in battery materials are absolutely critical. While advanced lithium-ion batteries, including lithium iron phosphate (LFP) types that offer better safety and longer lifespans, are still dominant, the research into next-generation tech is intense. Solid-state batteries are a huge area of excitement. They use solid electrolytes instead of liquid ones, promising improved safety, they're non-flammable, higher energy density, better temperature management, and longer performance. Several European projects are pushing for these fourth-generation lithium-ion batteries. Then there are sodium-ion batteries. These are expected to become much more competitive after 2025. They offer a cheaper alternative using more abundant materials and are great for stationary storage or entry-level electric vehicles, where super high energy density isn't the top priority. In fact, China launched the world's largest sodium-ion battery energy storage system in 2024. We also have flow batteries, which store energy in liquid electrolytes in external tanks, making them highly scalable for long-duration storage. And the innovation doesn't stop there. Silicon anodes are being developed to significantly boost energy density, and research continues into lithium-sulfur batteries. The global energy storage market is set for massive expansion, and materials science is at the heart of it. Next up, let's talk about green hydrogen. This is hydrogen produced using renewable energy through a process called electrolysis, and it's seen as a key clean energy solution. Materials science is essential for making it cost-effective and scalable. A lot of research focuses on improving electrolyzer components. This includes developing catalysts that use low amounts of, or are free from, expensive platinum group metals like iridium, especially for PEM electrolyzers. Scientists are also working on advanced membranes and ionomers as alternatives to PFAS-based materials, which have environmental concerns. Innovations in coatings for components like porous transport layers and bipolar plates aim to lower the operating voltage, increase efficiency, and extend the lifetime of these electrolyzers. And of course, we need advanced materials for safely and efficiently storing hydrogen, like improved carbon fibers for pressure vessels and novel hydrogen carrier materials. Different electrolyzer technologies like alkaline, PEM, anion exchange membrane, and solid oxide electrolysis cells each have their own specific material challenges and development pathways. For instance, alkaline systems use more widely available materials, while would. While materials, like iridium. So what are the overarching trends in this exciting field? Artificial intelligence and big data are playing an increasingly significant role. AI is being used to optimize renewable energy systems, from predicting when a wind farm might need maintenance and managing solar energy production, to speeding up the discovery and development of brand new materials. There's also a massive emphasis on sustainability and circularity. The goal is to develop sustainable materials, reduce our reliance on critical raw materials that are scarce or difficult to source, and design everything for recyclability and reuse. And of course, a primary driver for all this innovation is cost reduction, making renewable energy technologies more competitive than ever. Finally, government policies, subsidies, and international collaborations are vital for driving the research, development, and deployment of these advanced materials. The field of advanced materials science is incredibly dynamic, and it will absolutely continue to be a cornerstone in our global transition to next-generation renewable energy systems. It's paving the way for a cleaner, more sustainable energy landscape for all of us. That's all the time we have for today on G Fun Facts Online. I hope you're as excited as I am about how these material marvels are shaping our future. Thanks for tuning in, and remember to stay curious.